Hello everyone, we're going to talk about square roots. And the way that you can think of square roots is kind of like the opposite of taking a number to a power. And if you think about math, we teach you one way to do something, but then we teach you how to be able to undo it, how to get back to where you started. For instance, with you first, you learned how to add, so you were adding numbers, and it took you from one place to another. But then we turned back around and we taught you how to subtract, which allowed you to go back to where you started. It was like a cycle, adding and subtracting. The same can be said for multiplying and dividing. And really, in the same way, that's what we're doing. We learned how to take a number to a power using exponents, and now we're kind of learning how to go back the opposite way. So we must understand nomenclature. There is a number written outside of the square root symbol. This number is called the root index. So whenever they say a root index of, and they give a number, that's the number that goes outside of the square root symbol. We call the square root symbol a radical. This is a radical. Looks like a long division symbol except with this little tail coming off of it. Underneath the radical, we call that the radicand. So root index, the radical, and the radicand. And for this problem, what we need to understand with square roots is that there's always an understood 2 here. There's an understood 2 here if there's nothing written. So just this radical right here means that this is a square root symbol. Okay, just the radical written without a root index, there's an understood that there's a 2 there. And the square root of 16 equals 4 because 4 times 4 equals 16. And with talking about perfect square, here's a breakdown of perfect squares. What the perfect squares are is taking each number from 1 to infinity and just squaring it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And viewing that just in expanded form, all we're saying is 1 times 1 and 2 times 2 and 3 times 3. And if we view taking the square root of something and we're giving a perfect square, then either way you view it as this, or you actually picture it in here this way. This way right here is where I pull out a number. My root index indicates how many of those numbers have to be in there before I can pull one out. So I was given the problem 16 squared. So there's an understood 2 there for my root index. So I need 2 of a certain number before I can pull it out. Well, 16, factors of 16 are 4 and 4. And that is one of my perfect squares down here. 16 is a perfect square, which I understand that it's 4 times 4. This allows me to be able to pull out a 4. I can pull out one of these 4s from out of the radical and the other 2 just go away. Really, it's conceptual. It's how you see taking a square root. So let's go ahead and work some problems. Problem number 1, I say, is the square root of 36. Well, I can do it 2 ways. I can know, well, perfect square, so what I know is that 6 times 6 is 36, therefore it is 6, just because. Or I can view it to where, okay, I say, here is my radical, and 6 times 6, well, this is squared, so it's a 2, my root index, and I have to have 2 of a number in there, so I do. I have 2 6's, so that allows me to be able to pull one out. The second way is how I prefer to see it, especially whenever you get to numbers where we're taking square roots of numbers that are not perfect squares. Okay, so pause the video, and I want you to work 2 and 3, and 4 if you would like, but I'll show you 4. Okay, again, we'll look at this and we can say, okay, I know that 49 is simply 7 times 7. Therefore, the square root of 49, that symbol means therefore the square root of 49 equals 7. Or I can still look at it as being under the radical and say 7 times 7. Again, this is how I prefer to do it. There's an understood 2 because it's the square root symbol, so it means I have to have 2 of the exact same number underneath the radical. I do. I have 2 7's. That allows me to be able to pull one of them out. For this one, it is 11, because 11 times 11 equals 121. So what I have here is 11 as my answer. Or I can view it like this and I say, okay, there's an understood 2 for my root index. I have to have 2 of the same number under there to be able to pull one out. I have 2 11s, so I'm allowed to be able to pull one out, and it's simply 3. So what I have here is a cube root. No longer a square root. I have to write the 3 in there. It's mandatory. So this is how I view it, because we can have perfect cubes also. But remembering all of these becomes very difficult. So this is how I view it. I say, okay, let's break 8 down. If I were to factor 8, make a little factor tree, how many 2's do I have? 3 of them. It's really 2 to the third. I have 2 times 2 times 2. And how I view it, this is my root index. It is 3. I have to have 3 of a specific number before I'm able to pull one out. I do. I have 3 2's. 1, 2, 3. I'm able to pull a 2 out, and that is my answer. The cube root of 8 is 2, which we saw here. 2 cubed is 8. So really it's just one big cycle, like I showed you up here, how you work around and you work through. Okay guys, that is a basic introduction to square roots, and I need you to continue to watch the publisher's videos, structure and critically think about your homework, and good luck on your homework.